Hello class, welcome to our lesson today dealing with the surface area of cylinders. The past couple days we've been looking at the surface area of prisms, which is a bunch of rectangles and then two bases on the two ends. Today basically is just a glorified prism, known as a cylinder because it has circle bases as opposed to some type of polygon base. In order to be successful on questions like that, we have to be able to deal with circles really well. So remember, to find the area of a circle, you need to do pi r squared, so in this case it would be pi times 7 squared. 7 squared is 49, so that would be 49 pi feet squared. If you want to find that as a decimal, make sure you use your calculator and use the pi button. It's going to be more accurate than using 3.14. Please find the answer using 3.14 if it's an absolute last resort, but everyone should have the capabilities in some capacity to be able to find the area, or to find pi r squared using the pi button in some way. The circumference of this circle would be 14 pi, because if the diameter or the radius is 7, the diameter is 14, is just twice as much, and that would be 14 pi feet. I'm going to leave in terms of pi, I'm going to write answers in terms of pi. I'm going to leave the decimal for you to find later, just for time's sake. The second one, the most common mistake, is people for the area do 8 squared, but remember it's pi times the radius squared, and the radius here is 4, so 4 squared is 16, and then times pi would be the area of that circle. The diameter is 8, so the circumference would be 8 pi centimeters. Remember, area should be the unit squared, and the circumference, or the distance around the circle, should be just the units, because distances are the one-dimensional piece, and area has 2 dimensions. Okay, the net of a can should look something like this. There should be 2 circles kind of on the top and bottom. Think about the lid and the base of a can. And then I've seen this, a lot of students will take the labels off of a water bottle, for example, and when you kind of flatten that out, it's just a big rectangle. So companies, when they make labels like this, make a rectangle and then kind of glue it together to be onto the object itself. So the surface area of the can be found using finding the area of the circle on the top and the circle on the bottom, and the area of this rectangle as we flatten it out. That formula, unlike prism formulas, can be found using this, and normally this is given to you on a lot of formula sheets, but it's not hard to figure out. It's 2 pi r squared because there's 2 circles. So pi r squared is the area of one circle, and there's 2 of them, so it's times 2. The lateral surface, or the label I'd like to call it, is the area of this rectangle. Well, the easy part of the rectangle is the fact that this is the height of the prism, or excuse me, of the cylinder, and this height would be this number right here. The 2 pi r is a version of the circumference. Now, I could have written here pi times diameter, because really what you're doing is you're taking the circle and kind of flattening it out, and so the distance around the circle, or the diameter, pi times diameter, or 2 pi times the radius, is the distance of this length of the rectangle. The reason that most textbooks use 2 pi r instead of pi times diameter, though, is just for the fact there's one less variable to look at when it comes to these questions. So you'll want to write that formula down. This one's pretty consistent. 2 pi r squares are the 2 circles on the top and bottom. If the lid's open, maybe it's only 1 pi r squared, for example. And then 2 pi r times the height would always be the area of the lateral surface. So even though pi is involved and sometimes circles are a little bit confusing, a lot of students do a lot better on this than prisms because the formula is very consistent every time, because all prisms have, or all cylinders have, a circular base, as opposed to the prisms could have a different base depending on the polygon. Okay, so here's a soup can. It says the diameter is 3 inches and the height is 8 inches. So you need to draw the net. The net should be a rectangle with 2 circles on the top and bottom. Notice I labeled the diameter of this one and the height of the label. To find the surface area, it's 2 times pi radius squared. The radius, remember, is 1.5, not 3. So 2 times pi times 1.5 squared, plus 2 times pi times 1.5, which really is just 3 pi, which is the diameter, then times 8. Notice how I'm showing my work. I'm showing the setup, then I multiplied all the numbers, and then put pi after it, and then I found the answer by adding them all together. That's what your work should look like. That's the expectation about when we do these questions, is that you're going to have the original setup, kind of simplify, and then your solution, and that should be your answer for the surface area. If you want to find the decimal surface area, you just plug that into your calculator, 28.5 times pi. If you want the lateral area of this, which is just basically like where it says Campbell's tomato soup, just the label area, so not the top and bottom. So if a company wants to know how much should I expect to have an area for that label, now there's a little overlap because of the gluing and all of that, but we're just getting a basic idea here. That lateral area should be found just using this information already. The lateral area is just the second part of the formula, which is 24 pi. So I don't have to do any extra work in order to find that answer if I've shown my work correctly on the first part of the question. The lateral area should always be smaller than the surface area because the surface area includes the two circles and the lateral area does not. Your homework today is just dealing with the cylinder ideas. I'm trying to give a little bit more time because I want to make sure that this is really well done and ready to go. So if you were lost a little bit on the prisms, let's make sure we get that figured out. And then we can also look at the cylinders today. On 3 through 5, draw the nets out. And I know you can't see here what we need I'm kind of covering it up, but you need to show your answers in terms of pi and as a decimal when you find these answers. So your work should look similar to this idea. So 2 pi r squareds plus 2 pi r times h. I plug all that in, start simplifying the numbers, and then combine the terms together in terms of pi. Then at the very end, make a decimal answer. That's the expectation for these questions. The last group of problems, 19 through 22, are some review problems, but we want to make sure that we have the idea for the cylinders figured out really well as we get started on this lesson. Have a good day, everyone.